Good afternoon, everybody. Today, December 9th, 2019, purpose of this activity is to determine whether or not we have two parallel lines or two perpendicular lines depending on the slopes. So, for this first activity, we determined that the slope of line A, which is one on the left, go up 2, right 1, so your slope was 2, and it was positive, and the equation y equals 2x plus 6, because your y-intercept for line A is at 0, 6, and for slope B, again, up 2, right 1, slope is 2, and your equation y equals 2x minus 4. Make that 2 a little better, because the y-intercept is at -4, and we get this linear equation. So the linear equation, that is from what we've been doing prior to today. Similarly, slope, -3/2. You go down 3, 1, 2, 3, and right 2, 1, 2. Y-intercept is at +1. Line A crosses the y-axis. So again, this is y. This is x at the point 0, 1. Line B, same slope, -3/2. We went down 1, 2, 3, right, 1, 2. Equation, -3/2 x. Y equals -3/2 x plus 7. 7 is the y-intercept. Same slope, never intersect. That's what we notice about parallel lines. Perpendicular lines. For the first line, slope is 2, because we're at that so actually for this line, I noticed why some of you said up 4 and right 2. That's okay, because here everything was counted by 2, so we technically went up 4. We could have even done it here, up 4, and then right 2 to the right. So you have 4 up, 2 right. As a result, m equals 2. Now, for our other line, so line A, y equals 2x plus 6 is our linear equation. For line B, you have -1/2, so you go down 1. You only went down 1, or actually you went down 2, and then you went to the right 4. Again, have to simplify your fraction. So we went down 2, so it's -2, to the right 4, but we have to simplify it as -1/2 times x. And that's your linear equation. Perpendicular lines. Your slope. So here, only went up 1. So extra counting. And you went to the right. 1, 2, 3, 4. So for line A, slope is +1/4. And your x is -2. Y-intercept, that's where, again, y-axis, x-axis. If you look at this line, your B, slope is -4 because we went down 4. So since that's 4 down, we went down 4. You only went 1 to the right. So -4 or -4 over 1. And our y-intercept is +1. Line B crosses the y-axis at y equals 1. So opposite or negative reciprocal, that is for our slopes. So to be a little more, to clarify this a little better, slopes, opposite or negative reciprocal. The heart of today's lesson was the following. Parallel lines, it means your two lines never intersect. They have the same slope, and the symbol for parallel lines are just two vertical lines. Perpendicular lines, lines that intersect at a rectangular angle, 90 degrees. So slopes are opposite reciprocals. Or you could also say negative reciprocals, one or the other. And the symbol for perpendicular lines is an upside down T. So anytime you see an upside down T, that means two lines are perpendicular at a point. So that's just the general symbol. Now, perpendicular parallel lines, we identify the slope of the original line, or both lines, and we need to get equations in the slope-intercept form, which is y equals mx plus b. For example A, we needed to figure out the same slope for the four options. It turns out, first two were in the form y equals mx plus b. The second, problem C, part C, you had to divide everything by 2, each and every term. So 2y equals 4x minus 8 becomes y equals 2x minus 4. And then for the last problem, we had to do a couple little things. Distributive property, so negative 2 times x, negative 2 times positive 1, negative 2x minus 2. And then we have to subtract 3 on both sides, y equals negative 2x minus 5. Now, for determining perpendicular lines, you need the opposite reciprocal. So we're looking for opposite or negative reciprocals. So y equals 2x minus 5, that's option A. Y equals 1/2 x is option B. C, we rewrote as y equals 2x minus 4. And D was y equals negative 2x minus 5. Now, the choices that give us opposite reciprocals or negative reciprocal are B and D. So you started with positive 1/2. Negative reciprocal of positive 1/2 is negative 2. Now, for this last set of problems, we had to determine which line is parallel, perpendicular, or neither, given y equals 3/2 x plus 3. So for the first one, it was neither, because even though the slopes are reciprocals of each other, 3/2 is positive, so is 2/3. They're both positive, so even though they're reciprocals, they're not negative reciprocals. So it's going to be NA because the slopes are different, and these two are not negative reciprocals. They're just plain reciprocals, but not negative reciprocals. For the second problem, you have to isolate the y variable. This goes back to chapter 2 when we were determining how to rewrite equations in terms of different variables. It's just a matter of moving terms. So this first part of the problem, we had to move 2x to the other side of the equal sign. So we subtract 2x on both sides. So we have 3y equals negative 2x plus 6. And then for the second part, we had to divide each and every term by positive 3. And I'm going to make these 3's a little better looking, because I know today was strange with the board. So in the end, our result is 3y divided by 3 gives us a plain old y. Negative 2x divided by 3, keep it as negative 2/3 x. Positive 6 divided by 3 is 2. Look at our slopes. They're opposites, and one is the reciprocal of the other. That's a perpendicular line, or the lines are perpendicular to each other. This third problem, similar to problem 2, you had to isolate y. So you had to subtract 3x on both sides. And then the other part was divide each and every term by 2. And you have y equals negative 3/2 x plus 4. This is an NA because the slopes are different. Even though one is opposite of the other, it's not negative reciprocal. It's just a negative or the opposite sign. So not only they're not parallel because negative 3/2 and positive 3/2 are different numbers, but they're not perpendicular because even though one is positive, the other is negative. 3/2, 3/2. This slope was not inverted. We didn't take the reciprocal of 3/2 and made it 2/3, unlike the previous example. Now for the last example, again, get y by itself. That is your goal. So step 1, it's subtract 2x on both sides. So 5x minus 2x, let me make that a more profound, make that a little more profound here. Let's see, okay, that might work. I just want everybody to see we're subtracting 2x on both sides. And then your next step, after you subtract 2x on both sides, 5x minus 2x is 3x. And now, since our goal is to get the y variable by itself, so divide all three terms by 2, and then the result is y equals negative 3/2 x minus 1. So we have the same slope, different y-intercept. So as the result, these lines are parallel. So that's the notes for December 9th, 2019.